Today's lesson, we're going to review function notation and then talk a little bit about what's called function composition. So the first thing we just want to remind you guys is that this notation right here is called function notation. So that little f that you see, that's just the name of the function. So I could change that to like a g or an h or whatever. And it's just reminding you that, like, hey, whatever you get for f depends on what you put in for x. So that's all that notation means. It's no different than saying whatever you plug in for x controls what you get for y. It's just this time we're talking about whatever you put in for x controls what you get for f. It's just a little bit more fancy. And just friendly reminder, it's pronounced f of x, not f times x or fx. It's f of x. All right, so you're going to see these operations here. I want to make sure that you know what notations they're going to look like. So for example, when you see f plus g of x, that's how you would pronounce it, that means f of x plus g of x. So all I have to do is take the f of x formula, which is 5x, and add it to the g of x formula, which is right here. Then I just combine my like terms and I'm done. So it's not like simple, like really complicated math. It's very simple. All right, and same thing here, like this is subtraction. So a different way you might see this problem is f minus g of x. And it just means, again, f of x minus g of x. So I take my f of x formula and I'm going to subtract my g of x formula. Now subtraction is quirky because since there's two items in the g formula, you technically would want to put that in parentheses after the negative. A lot of kids forget to apply that minus sign to both of these. So typically if you put in parentheses, you won't make that mistake. And then 5 minus 20, we can consolidate to negative 15. And then we just keep going. So it's kind of like the same pattern over and over. This is pronounced f times g of x. And it just means I'm taking my f of x formula and I'm going to multiply it by my g of x formula. And I recommend that you use parentheses for multiplication instead of a dot, because usually when something's written like this, like your brain recognizes, oh, I need to distribute. Sometimes if we have a dot, we don't make that connection. So if I distribute, I get my answer and I'm done. All right, and then the last one is division. So you would see it written as f divided by g of x is how you pronounce it. And I take my f of x function and I put it over my g of x function. Now, we talked about when we were simplifying fractions that because there's the plus sign, you cannot just go cross things out. So I can't cross this x and this x out. I'm not allowed to do that when I have addition or subtraction. So what I'd have to do is factor first. So I know I can GCF the bottom. Once I factor, then I can cross out things. So like these x's, I can now cross out and I can reduce 5 over 10 to 1 over 2. The x plus 2 is just still there. And we can stop. We don't have to redistribute like this 2 or anything. You're just done. So I just have a few practice problems for you. We're going to start with addition because that's pretty easy. So they're going to give you a problem that looks like this. And we just want to realize, oh, I'm just supposed to add the two functions together. So my f of x formula is right here. 3x plus 1, my g of x is 2x, and then I'm just adding them. So the answer is 5x plus 1. And then sometimes, I'm actually going to skip over here to letter C next. You notice they don't have an x here, they have a 5. So all that means is that we want to do f of 5 and then add it to g of 5. Now this you have done for me. I have had you get f of 5 before. All that means is I plug 5 into my f formula. So instead of 3x plus 1, it's 3 times 5 plus 1. And then same thing with the g. I'm going to plug a 5 into the g formula. So now it's 2 times 5. And then I'm just going to simplify all of that. And I'm going to get 26 as my answer. All right, we'll switch over to subtraction. So if we see f minus g of x, we want to remember, oh, I'm just supposed to subtract the two functions, and then we're just going to fill in the formula for f of x minus the formula for g of x. Now, I didn't put parentheses around my 2x because there's nothing else with it. There's only one term in this formula, so it's not like I'm going to forget to distribute a negative. And then combine like terms to get 1x plus 1, and then you're done with that. And then I wanted to give you a multiplication one, but this time I'm going to use -3 instead of x. So same concept. I want you to get f of -3 and g of -3 by plugging -3 in for x. So there's my formula for f of -3, and there's my formula for g of -3. I want to turn both of these into numbers, and then I'll multiply them when I'm done. So I'm going to get -8, -6, and when you multiply those together, you're going to get 48. And then I have two division problems just so that we've covered every operation a couple times. So we are to divide our f by our g function. So it's easier to write it as a fraction. I'm going to replace f with x plus 3 and my g function with that trinomial. And again, because of all those plus signs, we can't just start crossing things out. We have to try to factor, and we can definitely use the x method for the bottom. Now I'm going to skip forward a little bit, and we're just going to say what you would get from the x method because we've done it so much this year. And then you can see, oh, I have matching pieces. I can cross those out. So now all I have on top is 1 and 2x plus 5 on the bottom. And that's my answer. Now, if I have a number in x's place, like if I have -1 in x's place, it's actually going to be a little easier for you. You won't even have to factor. So the first thing I would do is set it up like I did already, put the f over the g, but I can replace all the x's with -1s. Sometimes it's a little quicker just to set up the whole giant fraction and then go from there. You could also just get f of -1 and then get g of -1 and then just divide them. But I think it's just easier to set it up as a giant fraction and then plug in for x. So when you condense all that, you get 2 over 6, which is then 1/3. So that's a little bit of the function notation that I wanted to talk about in terms of operations. In the next video, I'm going to talk about what's called composition of them when we're going to plug them into each other. So when you're ready, you can open up the next video and we'll begin.